Hi everyone, my name is Dinos Hajiloizu and this is Lehin Han. We're going to do a presentation today on Beam and how it's used to prefabricate and modularize from a mechanical contractor's perspective. We're going to give you a quick introduction of Division 15 and what we do. And then we're going to talk generally about modularization, prefabrication, specifically in our field, which is mechanical installations. And then we're going to focus on a specific project, like a little example where we implemented Beam and we used prefabrication to accomplish our project. Hopefully we'll have some time for questions, but I'm not sure about it. So, quick introduction to Division 15 Mechanical. Division 15 Mechanical was established about 10 years ago from Bob Cook and Dale Miller. They told me that they don't like the picture, but I told them they can't blame the picture, really. They're sitting over there. So they both of them have strong background in commercial and institutional construction. And they're growing basically a company which offers quality mechanical services in BC. We're focusing generally in commercial institutional buildings and light industrial buildings. During the last 4 or 5 years, we've been also been involved in district energy. We've become really the leading mechanical contractor for district energy systems in Greater Vancouver. Just to give you a quick timeline of how we got into Beam and prefabrication, the whole story started in 2010 when Bob and Dale basically took a decision to start implementing Beam, and they hired Lehin in early 2011 as our first Beam coordinator. Our first project was on 2011, and actually that wasn't a Beam project. It was something that we worked together with the LEDCOR at that time, and they saw the value of incorporating the Beam component, and it was our first project, and we started that way. After that, basically, we got into prefabrication by purchasing the prefabrication software. It was FabMP at that time. And we went on 2012 to do our first Beam prefabricated project, which was the City of Vancouver energy transfer stations. We saw great value, and there was a decision taken to have our own fabrication facility. And in early 2013, we started implementing the implementation of our facility in Surrey, where we have a 2-acre lot there, and that allowed us to be able to do that. The fabrication shop basically is ready and now is utilized since early 2013. We are now in the process, after working with our shop and our softwares in a process of developing formal process and procedures and protocols for prefabrication. So Lehin is going to talk now about some of our BIM projects completed.
So as Dinos has said, our first project was Connect Place. This one, we had to really push for the rest of the project team to join us in using BIM. It was an amazing process, but at the end of the day, we were able to use BIM for coordination purposes. We did resolve some issues, which I thought was a big benefit to using BIM. The next project we worked on was the River District. This one was already constructed before we started BIM, so it was actually used for just some more accurate as-built. The next one here is our first actual fully BIM project. It was the UBC DS Phase 1. Here we saw a lot of benefits in using the laser scanning. It was an existing mechanical room, so a lot of the equipment was there. It was tight spaces. The laser scan really helped us in utilizing the space we had. But in this project, we realized that the software we were using, Revit, was just not enough. It wasn't accurate enough for our purposes. It didn't provide the spool drawings we needed for fabrication. So the next project we worked on was the City of Vancouver. This is where we started using our fab software, and we struggled with the new software, but at the end of the day, it provided better quality and accuracy for our fabrication. So right now, we're actually working on a YBR project. This one, it was a little bit different than the other ones. We actually got some models from the engineers. So we took those models and converted it to fab for our fabrication shop to construct. And also right now, we're working on this Sears project. It's mainly just for coordination. Oh, sorry. So it's mainly just for coordination here. But we did do a bit of prefab, mainly for the bigger spools that were just difficult for them to do on site. Full prefabrication was not really an option here because the site conditions just didn't allow it. Like, it was an existing building, so in order to bring those large pipes, it just wouldn't work. So here, this is the current project that I'm working on. It's the UBC DS Phase 5. It's a continuation from the Phase 1. So as I said, in Phase 1 we used Revit, but here we started using CAD MEP. As for COV there, it gave us a better quality finished product, and also it allowed for a lot of good feedback from site. So now I'll talk about modularization and prefabrication. So initially the tools we used were Revit, Navisworks, and our ferrofocus laser scanner. So there was a lot of research done before we decided to go with Revit. There's lots of different products out there that allow for BIM, but we decided on Revit because it was the most streamlined. Unfortunately, it's a great tool for design, but not for our application. As we are a construction company, it wasn't detailed enough for us, so it's a design tool, not a fabrication tool. So now we go on to our enhancements that we've used for prefabrication. So now we're working in CAD MEP. It's based on the Autocad platform. It's a full fab tool. So basically, it allows us actually, I'll go into this in a little more detail later on. Let's see here. So now that we've moved into fab, we realized that we need some hardware upgrades. Currently, we're using an i5, but now we're realizing it's not enough for our application, so we're going to be moving on to an i7 pretty soon here. We're originally using 8 gigs of RAM, but we've upgraded recently to 32. We're looking into solid-state drives, and I currently have 3 monitors that I'm working with right now, and we're looking into different graphics cards. The one I was using wasn't quite strong enough, so we're considering workstation graphics card, looking at different options there. Here's where I'm going to go into a little more detail about fab or CAD MEP. So as I said, it runs on the Autocad platform. It allows for a more accurate, or it has more accurate manufactured content than you would typically get in Revit. It also allows for easier creation of spool drawings, and also you can create more detailed bill of materials. Some examples of this in our bill of materials would look more into dimensions, materials, connections, and weights, rather than what you'd get in Revit, flows, and that sort of thing. So here I'm going to talk about the differences we have for, I guess, how to present our information to the fabricators, how to communicate with them. So what we need to consider here is we need new templates, new sheets types, new naming conventions. So what we have to ask ourselves is, what information do they need? We don't want to give them too much information, but we need it to be clear and concise. So here is an example of what you would see in CAD MEP. So that's just a T right there. So a lot of information is available in there, but once again, we don't want to overload our fabricators. We only want to give them the precise information that they need. So so now we need to consider what kind of procedures and protocols we need. How do we share this information with them, and what sort of feedback we can get from them. So for sharing of information, we've started using Autodesk 360. It allows you to just view the model in 3D space. So our guy on site, he has an iPad, and he can just kind of zoom it, focus it, even click on the specific items to look at the lengths, look at the elevation, that sort of thing. So due to the more communication requirements, we do need the extra feedback from site. For the detailed design, their feedback is very important. We can't always know what's happening out there, so for them to communicate with us is very important. We do also need to formalize this procedure, as Dinos has discussed. Currently, we're working on it, but it's a process for sure. Let's see here. I think I've discussed some of this communication and feedback, but review process. This is where Dale comes in a lot. So first of all, what we do is we need to get a material review. So to make sure we're using the correct items as specified. Then just a generic layout review, which will look at the space of the room, how we should lay it out. And then the last part is a detailed fabrication drawing review. So this is when we'll look at it, see how it's constructible, see where we need to split up our spools, and just generally the location of things to make sure that everything is as required. So right here, quality control. Now we have a lot more responsibility for the project team. They have a lot more involvement in sense of they'll be the ones requesting the BIM content for us, requesting shop drawings. They'll be the ones setting out the shop drawing submittals that we create. And if any questions come up, they'll be the ones sending out the RFIs. So in this case, this allows us to have more documentation for tracking. It's really streamlining it, so there's no question whether something was available to us or if something was missing. It's all there. So now I'll pass it on to Dinos for the modularization and prefabrication section.
So in order to be able to modularize and prefabricate, we had to take Beam to a new level. Our original version didn't work, and this is how Lehin explained what we had to do. Modularization, though, cannot be applied everywhere. There are certain factors, certain conditions that need to be met. So we cannot get a project and say, okay, this project or all our projects, they're going to be modularized and prefabricated. The project size, the complexity of the project, and the project schedule these are very important factors, and they play into our decision-making process. We have the pictures here of a very famous building downtown. I know one guy that already knows about that from Ledcor, and probably some of the women here are going to be very excited to know that Nordstrom's is going to be coming to town. I think my wife is. So we have an example of a mechanical room at the picture at the top right over there. The state of that mechanical room is nowhere ready for mechanical construction. It's plainly not ready. However, the truck at the bottom right, it's showing prefabricated components that they're leaving our facilities going to the job site. And a few months later, actually a couple of months later, we have that mechanical room already almost built. This is basically something that was dictated in order to meet the schedule. Prefabrication had to be implemented. The project location and the transportation factors are really important as well. One of the previous presenters talked about remote locations. In some instances, you cannot find people or experienced people that they can do the work, and therefore you have to try and do as much as possible, prefabricate it, modularize it, and ship it to the job site. The amount of modularization, though, it's always debatable. It depends on the accessibility, on the transportation options. Here's an example of an energy transfer station that you can have it skid mounted, shipped to the site. It doesn't work everywhere. It doesn't work in an example that we are going to, in our project that we are going to review in detail in a few minutes, because there is no way that a skid mounted energy transfer station is going to fit into an existing building. Therefore, we had to create smaller size spool pieces that they are going to be transported to the site and easily put together by our field guys. This is our original prefabrication attempts with on-site fabrication tent cities, what we call them. We created these temporary structures that our crews would utilize to put things together, but that's not the ideal situation. It requires space on site, which you don't get many times. It requires setup and downtime, and also you cannot control the environment. Therefore, basically, with the new facility that we have, we have a new fabrication shop where we can have a controlled environment away from the elements, dry, heated spaces. We have the tools and equipment, the proper tools and equipment that we need to in order to perform the job, and obviously we can achieve better safety and quality control, because here we have the ideal space to do that. It's away from a busy construction site and all that. Additionally, we have material storage. The material can be stored next to our fabrication shop, and they can have easy access. With that, though, we had to buy new equipment. Here is an example of a grooving machine, and we can see our yard supervisor working with that machine by himself, while on a job site scenario, probably would need 2 guys to just handle that machine, that piece of pipe, and groove it. Probably the time would be significantly higher. We have a forklift, and again, 1 guy with a snorkel attachment that he's using he can by himself move the pipe, take it to the groover, and groove it by himself. There are future plans to this facility, a pipe cutter, for example, a welding machine, an overhead crane, and a barcode tracking system where all the components can be barcoded and be shipped to the job site. With all this, we realized that our procedures, so there are many changes happening, and therefore our procedures had to be updated. New procedures had to be implemented, and therefore we are in the process of doing that. We realized that there is a need for a lot of collaboration between the different teams. Now we have a fab shop team that they need to be kept in the loop. There are a lot of responsibilities on the project management team that they need to coordinate a lot in advance. That's something that they wouldn't do before. We need 3D model approval. So once we generate the models, we generate not BIM models, but 3D models that we send to the consultants for approval. Obviously you can generate bill of materials. Our software can generate bill of materials that the project team can now order very accurately the amount of materials required. We have also established fabrication, or trying to, and we're implementing fabrication procedures and tickets. So once we generate the drawings, we have to find a way to communicate this to our fabrication shop. Therefore, we generate a fabrication ticket outlining the scope of work that needs to be prefabricated. This fabrication ticket will also provide information about the shipping requirements and about inspection requirements, because a lot of the inspections are now performed on off-site. And here's an example of an X-ray truck, basically, doing the inspections after the prefabricated components have been completed in our facility. Before they go to this job site, they are X-rayed. Well, that's a requirement for the project. Not all projects have this requirement, but that's an example where it works very well. Now we have also shipping considerations. So again, level of modularization is very important. Not all projects will accommodate this kind of receiving this kind of shipment on site in one go. And that's a very significant consideration when we take a decision how to the level of modularization and prefabrication. And the last thing, which is very important, is people. I mean, we have these procedures, we have these processes, we have these machines, but people are important. We need to make sure that the right people are hired and in order to implement these procedures. Right now we have a yard supervisor that it's basically help us run this prefabrication process. But eventually, as we grow, we see that there's probably going to be a need for a fab shop manager as well. I'll pass on to Lehin.
So I'm just going to quickly go over the goals and deliverables that we have. We're kind of running short on time, so I'm going to speed through them here. So first of all, we want to have fully coordinated mechanical rooms, drawings with clash detection. And then we want to have primary service corridors and shafts fully coordinated. Some small bore piping and terminal equipment connections. Automated hangar and equipment layout using the Trimble robotic station. This is where we start getting a little more into the fab side of things. So development of detailed fabrication process and procedures, that's the main one there. Building prefabricated components for out-of-town shipments. And then the last one here is expand and modernize our fabrication shop. And pass it back to Dinos for success criteria.
So we have our goals, but we have some criteria that we need to set in order to measure our success. And the first one is to improve the labor productivity. We have some real cost for developing the Beam, the 3D models. For developing the 3D models and for fabricating them off-site. So we are looking for a return, and we see this return coming from saving labor savings. Obtaining project opportunities due to Beam and Prefabrication capabilities, that's very important. We saw that in the next project that we are going to go through. Tighter purchasing control, it's also something that we see as a success criteria. We can generate detailed bill of materials, and we can make accurate material orders now. We can reduce or eliminate overtime, because now a lot of the work is done in the shop. And now we're going to go to UBC District Energy project. Phase 5. We've done phase 1. Phase 2 and 3 was an underground project with underground piping. The phase 5, basically, we have 22 energy transfer stations within existing buildings. So very quickly, what UBC is trying to do, they have a district energy system utilizing steam, so all their buildings are connected with a steam system. Steam is not viable anymore. They want to switch to hot water. Most of their buildings now, they have to be upgraded. Existing buildings, that's very important to know. There are existing buildings that they have to be switched from steam to hot water. This is what we usually, I think I skipped some things over there. In this project, Division 15 acted as a mechanical, as a prime contractor. So even though the majority of the work was mechanical, we had to coordinate the electrical component and the controls as well. The key parameter here is that UBC dictated when tendering the job that the successful contractor should be able to prove that they have beam and prefabrication capability. That was, I think, very key to the success of the project, and that was because they wanted to minimize the impacts to the occupants. These are existing buildings with students, occupied by students or classes with a lot of people. So that was a very important parameter for UBC. This is what we normally get from the engineers in these kind of projects. 2D drawings, schematics, and these are the buildings that we have to work with. I think I need to say nothing else here. The project schedule it was 12 months from September 2013 to September 2014, and the value was 4.8 million for the total value of work. Lahin will go very quickly through the data collection process right now.
So first of all, we got the IFC drawing specifications, and then we also looked at the shop drawings. So a lot of this was owner-supplied equipment. So we had shop drawings pretty early. There are still some other items that took a bit of time for us to acquire. Next, we went through all the rooms, laser scanned them to get a good idea of what was existing. And then we imported the equipment. That's right. Yeah. So we imported the equipment, set up the the systems, set up the specs. So with CAD MEP, that's a great benefit where you can actually compile the specific components based on your specs. You can bring in all of your pipes, your fittings, to the specific specifications you need. So, for example, 2-inch and above is SCED 40, below is SCED 80. It's welded, but secondary is grooved. All that information can be inputted in. Next is the point cloud can be attached directly into the Autocad platform. So this is a benefit, just because with it being imported directly in, you can model around the point cloud instead of having to kind of go back and forth and looking at it. The CAD MP actually has clash detection built in. So when you're modeling, if something overlaps or clashes, it gives you an indication right away, versus in Revit, you'd have to run the process to see where the clashes are. We also use Navisworks to perform a clash detection. And one thing I want to mention here is, I found this really useful, is from CAD MEP to Navisworks, you don't have to append the model and the point cloud separately. It's all in one file. You just bring in the DWG and it's all set up. Here I'm going to talk a little bit about the coordination with site. Since we do have a fab shop now, I find it's a lot easier for feedback with them. If I ever have a question, I just go out there, talk to them directly, and they can come do the same with me. And then also now with the updated IFC drawings, the project team will keep me up to date. They'll keep me in the loop, CC me in all emails that are relevant. One thing I want you to take is constant communication is very important. The site conditions are hard for us to determine through laser scan. So definitely we have to talk to them on site. They need to, even though we do have the scan, they need to be able to look through and just determine if there's any items that we might have missed. For example, if they're trying to core a hole in a wall, there might be a conduit that we might have missed. They're small, they're hard to see in the scan, right? Also, floor drains for housing pads, we just recently noticed one in our project. And these things aren't easy to see, but when you're on a site, it's a lot more obvious. So for them to review our work is definitely a must. So the approvals of our ISO drawings, we definitely need the approval of in-house for our routing. Then also we need a detailed review by our either our foreman or our our site manager here. So for example, the things they would look for is maybe location of the air vents, make sure they're on all the high points, location of isolation valves, make sure it's close to the equipment. Sometimes these sort of things get missed, and when you start building it, you realize that something had to have gone wrong there. It's definitely important for them to be able to review this with us and just double check all our work. So the last thing that has to be done is approval by the consultants. Once we are comfortable with our design, we'll send it out to them as a shop drawing, and they'll come back to us and let us know when we can start our fabrication. I'm going to pass it on to Dinos to review the fabrication process.
So once the layout has been approved by the engineers, by the consultants, then we do go and generate the fabrication drawings. So these are a lot more detailed drawings than the layout. Shows the spool pieces. These are drawings that they can be given to our fabricators and fabricate them without any questions, really. The way we transmit that information, the piece of information is basically through the fabrication ticket. Then the materials are all ordered and released for delivery to our yard by the project team. And now we have the opportunity to receive them and inspect them, see if there are bug orders, damages, and anything else missing. and then proceed to fabrication, basically. Once fabricated, spool pieces are inspected and then shipped to the job site. Now, challenges to the project.
So similar to phase one, some of the challenges here, it was, I guess you can call it a lonely VIM project. We were the general, but we mainly just got schematics. There was some 3D models that were provided to us, but there wasn't enough details in it, and it didn't always work with the site conditions. So the other thing is an existing mechanical room. There's a lot of restricted space. You see how short I am? I even had troubles getting through some of these rooms, so you can get an idea of what it's like. Here's an example. So it's very crowded. You see how the black pipe is actually what we routed through there. Next thing is managing the object library. So just keeping it up to date. There's not much else I can really say about that. The lack of our procedures. So we're still in development of a formalized procedure and processes. We need to increase our pre-planning and coordination. How to move this information or this process has moved from the site to our office. It's definitely putting stress on our office staff resources. I think this is Dinos' section here, yeah.
So I think we're running out of time. Very quickly, we're going to go through the benefits. We separated the benefits into two categories, for Division 15 mechanical and for the owner. Basically, we have, for Division 15 mechanical, we are able, through this process, to identify and resolve issues in advance. That's very important, and it's very valuable. Here is some examples with the pictures where we are showing the drawing from the consultant, which is not here, and we overlaid the point cloud. It's a mess. So here is the solution that we gave to the project. And this also expedited the installation time. So prefabricating offsite, sending it to our guys, eliminates all this guesswork that they had to deal in the past. Now we had to take out all these conflicts that we see here. We had to even find them before our guys even knew about it. Minimize the risk of costly mistakes, obviously. Improve safety and minimize material waste. We have the opportunity to order everything and in a just-in-time almost basis. And also we eliminate the time for creating as-built drawings because they're ready, basically. For the client, for UBC in this project, they minimize schedule delays, which was critical to them because they wanted to switch and energize the system right away. They minimize disruptions to the occupants. The majority of the work was done off-site. Pieces were sent to the job site. The work that we have to do at the job site was there, but it was a lot less. And of course, they have the benefit of reducing change orders because we can find ways and different routes now that they provide a less costly or a solution at no cost. And at the end of the day, they get a better result, a better installation, a high-quality 3D as-built drawing. If they want to get the model, they can. If they want to utilize the model for facilities management, they can. So these are benefits to UBC. Here is an example of the as-built drawings. We have some lessons learned to go in 28 seconds.
So I'm just going to quickly go through these. So basically, the first thing is expedite BIM design timelines. Just start as soon as possible and allocate more resources. Organization is key. just to make sure that we do a lot pre-planning ahead of time. Laser scanning was a very valuable tool. It helped jumpstart the design and establish and enhance formal prefabrication process. So that's something we need to jump on right away. Our short-term goals are upgrade our BIM computers, improve our fabrication process and procedures, improve our fab shop, purchase additional fab shop equipment, and obtain and implement the robotic station for layout. Our medium-term goals are to expand and modernize our fab shop based on capacity analysis. So additional welding, weld pipe fab lines, additional grooving lines, and overhead crane. Also to purchase a truck trailer for prefab material shipments to site. For our long-term goals, so to phase in the robotic station, phase in plumbing prefab, and also for phase in the packaging system for out-of-town shipments. Pass it to Dinos to finish off.
Well, I don't think we have time, but I think you get the message here. If you want to talk to us after for whatever, if you have any questions specific to a project or whatever, you can come and find us afterwards. Thank you, guys.